might be more than one kind of thermal switch. There are varieties. There's like physicals, there's mercury switches, there's pressure switch, temperature switches. There's all varieties of switches, and they all work different in different measurements of how they conduct potentially a thermal energy, whether it be transduced into a force, an energy, a motion. It's basically a few little physical principles, but like coffee pot, electric coffee pot will use a thermal switch that essentially detects the heating element and causes a barrage of switching on and off based on how hot the element actually gets as it's wrapped around a cooling structure. And if the element gets absolutely too hot, it will eventually turn off if you detect that the temperature rises to a certain limit on the element itself, which is directly on or very near the thermal switch, which technically all temperature can change to an elevation, you might say, because of the unified particle field theory effect of changes in how unified field changes by delocalization to the Earth or whatever, just as anything changes away from a massive object or any kind of object of particulate fields, it changes in energy rates and particle rates and how they all move and flow. Well, actually, if the temperature is more local, it won't adhere to as much ranging from change in temperature as long as it's pretty close to the actual temperature sensing position. So like it depends on what you're detecting the temperature from. Rather if you were detecting the temperature from the water, it would change drastically. But if you were detecting the temperature directly on a heating element, it's going to range pretty much more close than the water itself because of the dispersion factor of particles in the change of elevation or distance from an object or in relativity to a particle frame. This is just differences in how forces affect things quantumly in a particle field. And it really is pretty screwy, a strange thing to really sit down and put all the math or just measuring that all out and getting it right. You might not have to use as much math really. It's just like playing with a system for a while. It takes a while, so math might not really be easily represented in quantum physics more so than actual physical experimentation. But like, no, you don't know all of the actual particle interactions in math terms probably. If you do, that's pretty wild because I've never seen it before in my life. But good thing because you can actually do a physical experiment and just range it in, and say, well, that's the range for this position on this point in time on the Earth, which time is nothing more than the motion of objects relative to infinity. So, and that can be localized or delocalized. It could be entropic or enthalpic or whatever you want to call it. It's just the particle exchange system. It's a unified particle field with gravity and everything. And it's just all around the entire universe. And this is how you conduct thermal varieties of switches and thermistors and basically thermocouplers and thermal batteries and like earth thermal batteries and earth what have you, solar panels, batteries, everything. It's really just positive, negative energy, and you just range it in, and it's really simple.